Everyone, my name is Adnan, and today we are gonna study statistical hypothesis testing. So, if you only know the meaning of the words of the topic that you are gonna study, half of the job is done. So, what is statistical? It means that it's gonna involve some math, some calculation. Hypothesis, what is hypothesis? Hypothesis is like you propose something that this could be, like you propose an idea that is an hypothesis. Like you propose the idea that by taking tea the headache is gone. Like this is a hypothesis, and then we can test on your hypothesis. Like we can take a population, right? We can make two groups, right? One of them is gonna be our control group, one of them is gonna be our experimental group. We are gonna give uh, tea cups to one group and no tea to other group, and both of them initially had headache, but we will see that the hypothesis that you initially gave, that by taking tea headache is gone, is that hypothesis correct or not? We are gonna test that hypothesis, right? That is statistical hypothesis testing. So what is null hypothesis? Null hypothesis, or H naught, is like that hypothesis where that says that there is literally no difference of opinion uh, of your, like, okay, so null hypothesis says that headache is not gone by taking tea, while alternate hypothesis says that headache is gone by taking tea. Okay, headache is gone by taking tea, that is like H1, right? So you got alternate hypothesis, you got null hypothesis, and you can test which one of them is correct by doing a study analysis. Like you take a population, maybe you take a population of 50 people, okay, and all of them have a headache. Okay, you make two groups, 25 of them are gonna take tea while other 25 are not gonna take tea. Okay, and now the 25 which are actually taking tea, you will check how many of them uh, in how many of them the headache was relieved by taking tea. Okay, and the 25, they are not gonna have any tea at all, and you will check that how many of them are gonna have relief from headache. So maybe you get 10 of 25 whose headache is relieved by not even taking tea. But here you see that the 20 people, their headache was relieved by taking tea. Okay, so now your hypothesis that by taking tea headache is gone is proved, that more people are relieved by taking tea than those who are not taking tea. Okay, so like imagine you give a p value. You know what is p value? Is kind of your confidence on your study, right? And most most of the time it is set as 0.05. What actually is p value? It is like a 5% chance, 5% chance that your null hypothesis can be true, right? This margin of error is allowed by studies, right? So you can, like, out of the 100 people, only 5 will be having relief of headache by not taking tea. Okay, so that should be the chance. Okay, so statisticians have kept this value, p value, minimum. So your p value should be less than 0.05 if you want to say that your results are statistically significant. Okay, now imagine that you say that headache is relieved by taking tea, right? And you say my p value is 0.03. Okay, and now there is another study. Imagine this study was done in USA, and there is another study which is done in India. Okay, and that study says maybe your study concluded that 90% of the headache is gone by taking tea. In 90% of the people, headache is relieved by taking tea, while there is another study in India which says that 95% of the people are gonna have relief from the headache by taking tea. Now they said that our p value is like they said that our p value is 0.04, right? So you wanna test that. You see there is a difference of 0.01 in both p values, and there is a difference of 5% difference between the two studies which were done independently. Now you wanna check that is this difference actually there or not, right? You want to check that is the study which was done in India and study which was done in US, maybe one of the study which is done in the maybe Pakistan, it might say that there is no association of headache and tea. Maybe there might be a study that can conclude that, and they can also give a p value, right? So if you want to compare the two p values and you want to see that is the difference that you can actually see them in them, 0.01 difference, is that difference actually there or not? For that we have specific test which you can see. We have the t test, right, where you can compare two groups on their numerical values, right? Your p value is a numerical value. You have 0.03 and 0.04, there is a difference of 0.01, that is kind of numerical values, right? So you can compare numerical values by t-test. If there are two groups like India and USA, and three groups, you can also compare three groups numerical p-values, um, average, you see the means, average. So you can compare the means. Maybe let me give you another example. A study says that the mean blood pressure of people in United States is 100 millimeter of mercury, while another study says the mean blood pressure of people in India, it is 110 millimeter of mercury, right? So you see the mean blood pressure of the people of India is 110, while it is 100 in the people of United States. There is a difference of 10. Okay, and if you want to check that is this difference actually there or not, you will do the t test, right? Maybe there is another test, there is another study in Pakistan, and they say that the mean blood pressure is 90, not 100, not 110. So if you want to check that this difference between the three groups, you will do the ANOVA test. Okay, this was for those variables which you can count, okay, numerical variables. But if there were categorical numerical values, right, you can't count them. Like imagine there was a study on the blood pressure between different age groups, right? So one of the study says that the mean the proportion of men, like you take 20 men and 20 women, and then you reach a conclusion that 50% of the men of a certain population have 100 millimeter mercury blood pressure, and 60% of the females of a population have 100 millimeter 110 millimeter of mercury of blood pressure. If you want to check the difference between two categorical values, here this percentage is a categorical value, and if you want to check that the difference between the two values actually exist or not, these are the categorical values, proportions, right? They are not exact numbers. So if you want to check that the same way, for if the population sample is small, you can do the Fisher exact test, or if it is a large population, you can do the chi-square test. Now for USMLE step 1, you don't have to go into the details of the test. There exist formulas for them, and you have to put your values and reach a conclusion. But for USMLE, you only have to do that there exists a proper algorithm that which test will be applied. So first thing, you should know the variable which you are comparing. Second thing, you should know the groups that you are comparing. So you can reach four tests: Fisher exact test, chi-square test, Nova test, and t test, and you can like apply a single test on a single population.